I'll come back to this in a moment. I'm sure some of you want to see exams in the past, right? You come here and go to a previous semester, let's say for 2013, and you can see some exams. I do want to emphasize that we reordered the material this semester. In the past, we started talking about recursion early on. This semester, we decided to spend more time on pointers before we talk about recursion. So if you look at the exam questions, some may not be right away obvious to you. But I want to give you one specific example, like question number 3 of the last semester. So ask you to consider the following program. There's a form function call. There's a pointer, and then there's a main function, and ask you what's the value after the function finishes. You should be able to do a question like this, and explain how you get the answers. I think I'll talk about this later today. There are different ways to solve this problem. One way is to use call stack, and some people did that. Some people show me they did that and correctly. And there are other ways to do this. So I'll talk about this in a moment, later today, after I talk more about pointers. One thing you also need to be aware is sometimes I still don't understand. I say write the variable FV and count. Every time I get a few students, they just write 1. I ask you 2 questions, you give me 1 answer. Every time a few students does that. I don't know why. Okay? And for some questions, I also say, please explain how you get the answer. An answer without explanation will receive no point. And every time, students write the answer without explanation, and they get 0. Okay. I don't know. This is the largest part I can find in LaTeX. Explain. Okay. If you don't explain, you get 0, and don't count. And even students say, I don't know. I need to explain. I don't know how to respond to that. Okay. I really don't. Anybody has any suggestion? If somebody says, I don't know, I need to explain. I don't want my answer, and the answer is correct. Why do I get 0? And I said, you don't have explanation. And the student says, I don't know, I need to explain. How do I answer that question? Any suggestions? I don't know. Okay. I think it's large enough. Okay. So, and last semester I decided to just put the 2 numbers there. And I still get a few students that only answer 1. Maybe they don't know how to answer the other. Maybe that's the reason. Okay. Okay. Anyway, so I tried to explain to you the common mistakes students make. And okay, let me show you another exam. Also, I don't know whether anybody has told you how to answer an exam. This class is not that big, but imagine you are grading exams. You don't want to spend 20 minutes per exam, do you? So it's not we don't want to spend time on the exam, it's just we want to be efficient. If your answers are very difficult to find, guess what? We cannot find it. And, okay, so I think we don't need to worry about this one right now. Okay. And sometimes we ask students a question, and the answer is unique. Let's say, is A 0 or not 0? And some students, every semester I get a few students, they say yes, and there's another place they say no, and I don't know which one to pick. And I always choose the one that is wrong. So if you need to decide the answer, either yes or no, those kinds of questions, right? If let's don't start thinking, I write both and I get 50% points. It doesn't work that way. Does that make any sense? So make up your mind and write down the answer, mark the answer clearly. Okay. So the answer question where to find exams. There are many more exams in the past. For example, for 2012. And if you scroll down, where's the exam? Must be somewhere. Okay, maybe go to, oh, because for 2012 we did it online. Okay, that's to spring 2011. There should be exams here. Yeah, you see exams. Okay, so there are a lot of practice exams. Next Tuesday, we still have class next Tuesday. Bring your questions, if you have any. If there's no question, I will cover more material. The material for next Tuesday, if it's new material, it will not be in the exam in the evening. Okay? Any questions about exams? Okay, so just to help you write your exam, this is not just 2CD4. Sometimes you write a lot. We don't know which one is your answer. So you may want to just mark, okay, my answer is this. A is 5. You can write explanation or your working process. The exam should be single side, printed single side. You can use the other side for whatever reason you want to use. So there's a plenty of space. But that doesn't mean you should write a lot. If you are finding you are writing a whole page of essay, you are probably going in the wrong direction. We don't expect you to write a novel for the exam. Okay. Any questions? I want everybody to do well. This class is not curve graded. Means if everybody does well, everybody gets A. It has not happened to 2CD4 yet, when I teach it. Let's see whether that will happen this semester. Everybody does well, everybody gets A. And just in case that happens, but again, it has not happened yet. If nobody does well, I'll see everybody next semester. But that has not happened either. We always get most students pass, and a few students want to do it again. Okay, so remember, exam next week. Any questions? All right, what did we talk about last time? It was 2 days ago, right? What did we talk about last time? Andy on try, since last time I picked you?
We talked about heap memory.
Heap memory, okay. Tell me more about heap memory. Anyone else can help? Yes, please.
You have to allocate heap memory and release it.
Okay, you can allocate and you have to release it. You have responsibility to manage the memory. So let me give, why do you want heap memory? Because stack memory is too restrictive. If you need more memory, sorry, if you don't add, the amount of memory you have is determined when you write your program. If you write your program and say, I want an integer x, you get enough space for integer, not more. If you say, I want character, a string, I talk about string in a moment, you get enough space for 10 characters, not more. Some, I should say, some C compiler, they actually allow you to do this is a variable that is determined at runtime. That's not the use in this course. So for this course, 2CD4, this must be a constant. So stack memory is too restrictive. In many cases, you need more memory, or you need more freedom in memory. For example, if you want to find out how many students are in 2CD4, you don't know how many students are in 2CD4, so you cannot pre-allocate. Say, I think there are 20 students in 2CD4. If there are 21 students in 2CD4, your program has a problem. Right? So you need the freedom to allocate memory as you need when the program is running. So stack memory, let me just summarize what I have said so far. it's determined writing the program. Heap memory, you can allocate, and you can release when the program is running. How do we allocate stack memory? Heap memory. You'll do something like the following. You'll create a pointer. I'm going to use integer as example. It doesn't have to be integer. When you do this, this is your stack memory. This symbol, address, there. And the address is given to you, whatever the operating system gives to you. So I'm going to use 100 as example. Value is garbage. And then you can allocate memory on heap where you say ptr equal to malloc. You determine how many you want to allocate. LEN is your length. Let's say your length is 10. Means you want to allocate an array of 10 elements. So in your heap memory, this is what it looks like. You have symbol, address, value. This will be ptr 0, ptr 1, to ptr 9. Remember, array index starts from 0. There will be enough space for 10 elements because you say you want 10. And the address is given to you by the function malloc. That's a built-in function in C. Let me say the address is 2000. So this will become, 20,000. And this will become 20,001. Any questions so far? Why do we need size of? Because the size of integer can change on different machines. Some machines, size of int may be different on different machines. Most common size of integer will be 4 bytes. But don't be surprised if you see a machine where the size of integer is 2 bytes. On some microcontrollers. So if you want your program to be running on different machines, you want to make sure you don't use the wrong one. So size of will give you the right size for a particular machine, the machine you are running. You need to recompile your program. You want to make sure the type match. If you say integer ptr here, you want to make sure this is integer. There's no star here. If you don't match the type, you are asking for trouble. The behavior of the program is undefined. Yes, please.
Why is it size of int plus length? Why is it size of int plus
It's not
length?
plus, it's multiple.
It's multiple.
Oh, it's multiple.
Okay. Sorry, it was not clear. Okay. Any questions so far?
What does the malloc function do?
What?
What does the malloc function do?
Malloc will give you a piece of memory on heap. And you will return, malloc will return the address of the beginning of the memory space. You will return 20,000 in this case. Is another hint?
Yeah. PTR has address of 100 and both of 100 and 20,000.
PTR's address is PTR is
Pointer.
a pointer, but it's a local variable, right? So it has to occupy space on stack. This variable will be addressed because it's a pointer, and that address is a piece of memory in heap. Heap memory and the stack memory do not overlap. Operating system guarantees that. So that's the reason I give a bigger variable here. Does that answer your question? So what does a malloc do? Malloc will give you the address of a piece of memory in heap. If you give something, malloc can fail. What does it mean? If you say, give me ridiculous amount of memory, 20 terabytes, operating system will say, I don't have it. Then in that case, you will return. Does anybody know what happens? There's a spatial memory address that's not valid.
No.
No. When malloc gives you no means,
How do you know if malloc gives you no?
okay, so you say PTR equal to malloc, and if PTR every time you do malloc, you should check. This is a common mistake. Sometimes people write one equal sign there. Don't do that. I'm sure you know why that's wrong. If you don't write one, you are assigning no to PTR, not comparing. Okay. Malloc, if length, you give length, malloc guarantees the memory will be contiguous. The memory will be all together. It will not be scattered around. And when you do this, PTR variable is the address of the first element. What's the first element? It's PTR 0. That's the first element in the array. Let me just finish, okay? And the address of the first element is you add ampersand in front of it. Therefore, PTR 0 is the address of PTR 0. Yes, go ahead.
Yeah, will malloc return null if it cannot assign memory in one string block?
That's correct. If malloc cannot find big enough memory that's contiguous, you return null.
So even if I have enough space for it, but it's not continuous, I won't be able to assign it.
That's correct. So this is a more advanced topic. You will learn this in operating system. Malloc, let's say this is your heap memory. I just mentioned very briefly. Your heap memory. If you do malloc once, your malloc will find, okay, this is the memory you want. You ask for so much. The next time you ask, maybe malloc will give you this much memory. And then and so on and so on. Then sometime later you release some part of memory. So after a while, your heap memory will look like this. Some occupied, some free, some occupied, because you release some of the memory, and so on. So let me just draw maybe a few more. Because you allocate, you release, allocate, release. Then even though you have enough memory overall, but you don't have a one chunk of memory that's big enough, then malloc will fail. This is a problem in operating system called fragmentation. You'll learn this in operating system. And operating system, depends on operating system, sometimes they will defragment. Sometimes they don't, depends on operating system. So it's correct, if you have a memory but not big enough for continuous chunk, malloc will fail.
I don't get why is PDR equals to none, then the malloc fail. Does that mean the memory is too large?
It's not PTR equal to null makes memory allocation fail. It's memory allocation fail, malloc will give you null. If you make the length very, very big, then since malloc will guarantee the memory is continuous. Okay?
So if a star PDR equals to none, can we still do the malloc?
If you can do malloc later, but if you call, maybe like it's getting messy here. This is what you usually do. If you say PTR equal to malloc, and then and then you try to release unused memory. And then try to do it again. Or you probably will put a while here. Do while Does that make some sense?
Okay.
If it fails, you try to release memory. See whether you have unused memory, so you release it. Does that answer your question? Kind of? Yes, please.
If it's returning null, then it won't take any memory, right? Then what could you release?
Somewhere else. Other piece of memory. Not null, but not PTR, but somewhere else. Yes, please.
So, when you said pointer equals malloc, and then if you printed that pointer right afterwards, what would its value be? If you just printed the...
If you print the value here,
Yeah.
depends on what malloc gives you.
But it's going to give you the address, its value will be the address of the first
Its
element.
value will be the address of the first element in the array.
And then if you do ampersand pointer, what would it be?
Ampersand pointer, ampersand of what? PTR?
Yeah, PTR, sorry.
You want PTR or PTR 0? Okay, so coming back here, if you do ampersand PTR, what do you get? 100. If you do ampersand PTR 0, what do you get? Somebody help me? 20,000.
What if we just do PTR? Isn't it still gonna give you 100?
If you do PTR, what do you get? 20,000. When you do PTR, what are you asking? The value. Just like, think about if you do integer A is 20,000, and then you say A. What is A? 20,000. Does that make any sense? Does that answer your question? How about you? Did I answer your question?
Yeah.
Okay.
Thank you.
No problem. It's good to ask questions. Make sure you understand. Okay, any more questions so far?
How much memory does the pointer keep?
Okay, how much memory?
Inside, right?
How much memory does this one hold? Right?
Yeah.
Is that your question?
Yeah.
That depends on your computer. If you are using a computer both after 2008, that's probably 64-bit. And if before that, that depends on which computer you buy. But in 3CD2, you will learn how to program tiny controllers. Those controllers, maybe in your Christmas music card, they are not 64-bit computers. They are probably 8-bit computers. So in that case, the pointer space will be 8-bit. So it's machine dependent. The space occupied by a pointer is machine dependent. There was a famous quote in 1986, around that time, maybe 88, by somebody just retired from a major software company. I will not tell you the name, you can guess. He said, who would need more than 640 kilobyte of memory? Have you heard this quote? Okay, don't tell me who said that. You know this one, right? It's famous. That was a still very young company at that time. And I'm sure all of you have paid money to that company. It turns out everybody wants a lot more memory. At that time, the person thought you don't need a lot of memory for your computer. But the reality is everybody wants more and more memory, and that trend has not stopped yet. So your memory pointer gets bigger and bigger as new machines get designed. 64-bit will probably be here for a long time, because 64-bit is a lot. So, okay, that's a long answer to your question. Any other questions? Okay, now if you are not sure what really this means, what is PTR, let's say X means? What does this mean? Again, depends on the left side or right side. Let's say I do the right side first. It's the right side of assignment. Now this does not always need to be assignment. You can say, for example, you call a function. That is considered the right side, because you are reading it. We usually say right hand side, and sometimes you see RHS. When you do this, it means the following. You will take PTR's value as an address. You add X to the address and get a new address. Now if it's the right hand side, that means you'll read the value at this address. If the left hand side, means you'll write a new value to that address. So if I say PTR, let's say A equal to PTR2. So that means I take PTR's value as address, so I get 20,000. I add 2, X is 2, so I get 20,000 and a 2. And then read the value from the address. So you take this one and assign to A, assuming you have some meaningful value there. Otherwise, it's garbage. If you say PTR 3 equal to minus 7, that means you are going to write minus 7 to the address to 20,000 plus 3. 20,000 comes from PTR, 3 comes from here. So this is read. After you are done with this piece of memory, you don't need it anymore. You need to say free PTR. There's no size. You will free the whole chunk. You cannot free part of it.
All the values will be gone. Garbage.
Oh, everything here will be gone, garbage. Be aware, if you say PTR free after PTR, PTR's value is still 20,000. This value is not changed. Even though this memory is no longer accessible. So if you say free PTR and say PTR 1 equal to 2, your program will crash. Because you try to modify a piece of memory, that's 20,001, but it no longer belongs to you.
But you will still have one, like in the beginning, just 20,000.
Because PTR's value is still 20,000. So here you try to write 2 to address 20,001. Since you already released the memory, this piece memory is no longer yours. Just like you move out from a dormitory, right? You try to break into a dormitory, you leave last year, but you don't live there this year. You try to get in, somebody is going to call campus police.
But the PDR's value is still 20,000. Can you modify the address 20,000?
No.
No.
That piece of memory is gone. Yes.
Once you free the memory, does the value inside that memory change, or will it still be what it was?
It will still be it was, but you don't care, since you have no access. Just like you move out from a dormitory, you ask, is the furniture still in the same place? Why do you care? Right? Does that make any sense? Yes.
What if you write PTR 0 equals to 2? Does that crash still?
PTR
0 equals to 2.
equal to 2. What memory do you free? The whole chunk.
But
So this is also gone. You don't have access to this piece of memory. The whole chunk is gone. I am not releasing part of memory. C does not allow you to release part of memory. When you release memory, you release the whole chunk. Everything here is gone.
But the value is still 20,000.
Yes.
So
That simply means you cannot use it.
okay.
Does that make sense?
Kind
That's
of.
C's design. Okay, you have to understand C was designed maybe even when some of your parents were born. Okay. Now, students are getting younger and younger compared to me. You have to understand C's design philosophy. The philosophy is we do not do anything unless you ask me to do. That's the C's design philosophy. And when C was designed, you need at least a master degree, probably a PhD degree, to write the computer program. So the assumption is every problem is your problem. You try to use PDR error free. I told you not to. If you do it, it's your problem. That's the design philosophy. Why? Because it's faster. Does that make some sense? You have to understand the thinking behind the design philosophy. If you don't ask the program to do anything, the program is not going to do anything. You say free this piece of memory is gone. You did not say reset PDR. You did not say that. So PDR value is not changed. Like it or not, that's the way C is designed. And the good thing is, it's faster if you do it right.
20,000 is still there.
Go ahead, yes.
Then why doesn't PTR 0 crash? Because 20,000 is still there, isn't it?
No, PTR is still there. PTR is there. But this piece of memory is gone.
20,000 is also gone?
The whole chunk, no. This value,
Okay.
PTR is in your heap. I mean stack, I'm sorry.
Oh.
PTR is in your stack. Its value is 20,000. So PTR is still there because it's on the stack. But 20,000 is no longer valid memory in heap since you have released it.
Oh, points, okay.
Does that make sense?
But let's say, okay, never mind.
Yes, please.
If we say int a of 10, and
Int?
we're creating an array
Int,
a of 10,
okay.
would this be on the heap memory or stack
It will be a stack memory. Because you create when you write the program. So stack memory, this will look like the following. When you write, I was about to say that in a moment, but since you asked. When you write integer A10, that means in your stack memory, you have A0, A1, A9. And again, it will be guaranteed the memory will be continuous.
When you quit the function, specific function that makes use of heap memory, when you return the function to main, does the heap memory go all
The rule is very simple. Okay? First, you have nothing to do with heap memory if you don't use malloc. You are not using malloc, this will not be a heap memory. First rule. Second, if you malloc, you have to free. If you don't free, the heap memory still belongs to you. If you don't free, you have something called memory leak. And memory leak is a very, very serious problem. And some people call it silent killer because you don't see it. The program doesn't seem to have a problem for a while. And then you'll crash sometime later. Yes.
So like, how do
I'll
you,
talk about memory leak more in a moment. Yes.
yeah, if you have a memory leak, but then you still freed, it looks like you freed everything. Like then what's the problem?
Say that again. I don't understand.
I mean, like you can have a memory leak, but then like for every malloc, if you have a free, then it should be fine.
If for every malloc you have a corresponding free,
So what if I have like two like if statements and then there's like a malloc and then two frees.
you cannot free the same memory twice.
I mean like depending on which statement like activates, it frees it. Like,
Then you have to say if else. You cannot for every successful malloc, you must have one and only one free. So if you say PTR equal to malloc something, and then sometimes you say free PTR, and then for some reason you say free PTR again, your program will crash. Guaranteed.
Okay, how about like I have like two for statements separate, and then they have one malloc in each of them, and can I outside of both of them say free at once? Because like, or no, I mean like no, like an if statement and an else statement, right? And then like and then there's a malloc in each of them, and then like a free after all of it. Is that okay? Can I just free it all?
Are you following this rule?
I am, right?
Then that's fine. For every malloc and the free correspond to each other 1 to 1. That's a very, very simple rule, and it's a rule many people forget. How do you not to forget? Did I answer your question?
Yeah.
Okay. For example, if maybe you say if something, I will malloc maybe a different chunk of memory. Maybe you allocate different chunk, different size. Then here you say if you need to check whether your malloc fails, right? And then you do something and then you say free. Since you will only allocate here or here, since if else, so you have only one, then free is fine. How do you get a memory leak? There are many ways to get a memory leak. For example, if you say PTR equal to malloc, and suppose if that means malloc succeed, right? If it's not no malloc succeed, sometimes you say PTR equal to malloc again. Then you cause memory leak. Because when you say the first malloc, your PTR is in a stack. First malloc will give you a piece of memory. Let's say it's 20,000. And this is a piece of memory you allocate. And you call malloc again. If malloc succeed, okay, if malloc succeed, you're guaranteed that's a different piece of memory. You will not give you 20,000 again. If it succeed, it's guaranteed by the operating system. So we give you another piece of memory. Let's say another piece of memory is here, 40,000. So this becomes 40,000. Why? Because you assign to PTR. So you get another piece of memory. What happened to this one?
Leak.
If you don't have a way you lose 20,000. If you store 20,000 somewhere, then that's fine. If you don't have a way to store 20,000, then this memory is still yours. But
can't
you don't have
create
a way to
it, right?
access it. It's
You
gone.
can't create after, even if you do like free malloc, free PTR after that, the 20,000 is then it's not going to be free, right?
If you say free here, which one are you releasing?
40,000.
40,000. So this one have memory leak. Does that answer your question? Yes, please.
How big has the variable actually going to be that you use the heap memory in practice?
How much memory do you need to use for heap memory?
Yeah, I mean, you can use the stack as well, right? But you can use the stack memory as well.
Well, heap memory gives you what? Freedom.
Yeah, but in practice, in which cases do you actually use it? Because if you...
Every single day.
Okay. So
I guarantee every non-trivial program uses heap memory.
Yeah, but if I create an array, let's say what we did before, of 10 integers or something.
Okay.
Would you use the heap memory?
You use heap memory for any non-trivial program because you simply do not know how much data you need. Okay. Does anybody know 2 days ago was the 10-year birthday of which company? Facebook. When you create Facebook, imagine how many users are you going to have? Do you know?
No.
How can you allocate stack memory?
Okay.
I'm going to say, I'm going to create a company. I think I'm going to have 1 billion users. Let me write a program that can accommodate 1 billion users. Are you going to do that? Well, first you are probably going to spend $500,000 to buy machines to have a billion users, right? Do you know how many companies they think they are going to have 1 billion users and never get there? A lot. Okay? So you'll say, okay, let me be careful. I think I will have 10,000 users. Well, what happens if you have 10,000 plus 1 users? What happens if your company is successful? And you have 1 million users, you're out of luck. Does that make any sense?
Yeah.
So for any non-trivial program, you have to use heap memory. I don't see any way around it. Simply because you don't know how many you will have. Now, Facebook or any, it's actually more complex than stack heap memory. We'll talk about something called dynamic structure later. But you need to use heap memory for practically any non-trivial program. Yes?
Can you talk about a little bit more about array of strings? So when we have array of strings, do we need to...
I'll get there in a moment.
Okay.
Okay. Any more questions about heap? Okay. I will talk about that in just... Yes, go ahead.
So when you have array of strings, do you need to allocate all the memories together at once, or do you need to allocate each string?
You need to allocate each string.
Each string.
Yes. Okay. I need to take one intermediate step before I answer that question. Okay. Any more questions? Okay. So let me talk about assignment. I'm sure many of you have are thinking about that. By the way, the assignment deadline is extended by 24 hours, so it's due on Saturday because the school was closed yesterday. Okay. Now let's imagine you are going to write a function. The function is this one. I will say I'll create my malloc, and then I have something here, and then I give an integer n. This function does the following. Let me say I want to use integer. This function will allocate memory for n integers. And I'm going to put PTR here. And the address of the allocated memory is stored in PTR. Suppose that's the function I want to write. My question is, what is the type here?
What's the type of what?
What's the type of a PTR? Okay, let me say what the function does again. This function is going to allocate memory for n integers. So you know somewhere you have a malloc. Size of integer multiplied with n. You know somewhere inside the function you are going to do that. Does that make any sense? Okay. And this one will assign to PTR somehow.
You need to send a pointer then.
You need to send a pointer, yes. So, okay. The first version of this function is this one. Since I want to put address, so I'm going to say PTR and integer n. So I'm going to say PTR equal to malloc. And then how do I call the function? I will say integer p, I'm going to use p, star p. I'm going to call the function myalloc. P, let's say 20. Will this work?
Yeah.
Raise your hand if you think this is going to work. Raise your hand if you think this is not going to work.
No, it's not going to work.
Raise your hand if you are not sure. Okay, thank you. Okay, whenever you have a question like this, the first line of defense or offense is to draw the code stack, to draw the memory. Okay, so P, if address, that's 100. Current garbage. Okay, I'm going to call function malloc. I have returned location. It's going to be the line after. This function is void, so I don't have variable address. And the function has argument PTR. So let me write 101, 102. I give P, so what does that mean? I'm going to copy that. So it's going to be garbage, because I give P to the PTR. When you call a function, you copy the variable. And then you have argument, so that's 103, this will be 20. How do you get 20? Because it's 20. When you call a function in C, C has only copy by variable. Means the variable will be copied to the argument. C has only copy by variable. C does not have any other way of calling functions. C++ has copy by variable and copy by reference. C++ does that, and Java. C does not. C has only copy by variable, means you copy the variable here when you call a function. Some students invented a concept called copy by address. That concept does not exist. I don't know why every semester student says, how about copy by address? That concept was invented by every semester, one or two students will invent that concept. That doesn't exist. So if somebody asks you, you'll say, doesn't exist. There's no such thing. Copy by variable. You take the variable, you copy to the argument. Any questions so far? Okay. So once you enter the function, you'll call malloc. Malloc will give you a piece of memory. Let's say it gives you 50,000. So you change this to 50,000. As this malloc. And depends on n, this n will be 20. Now the function doesn't return anything. When function finishes, what happens?
Does not work.
This frame is popped. What happens to P?
Still stays. Not
Still garbage. If you want to modify something in a coder, you cannot give the value. You have to give the address. So this doesn't work. Any questions?
So is there such a thing as sending %p?
Yes.
Or do you have to use pointer by pointer?
Stay with me. Okay? So this doesn't work. If I want to modify this one, my intention is to modify this one. So I cannot give the value. I have to give the address. You seem puzzled. What's your question? Yes.
No, I'm not.
Okay. I thought your face looks like don't believe me. Are you okay? Good? Okay. How about you? Okay. The rule is the following. If you want to modify something in a coder, you have to give the address. You cannot give the value. You have to give the address, so you will modify P. Otherwise, whatever you do inside is not going to take any effect after the function returns. So this doesn't work. What are you going to do? You are going to say my alloc Okay, so let's see how this works. Let me get another piece of paper. So I will still say void. I know it has something to do with integer because I want integers. Something inside. And then I will say integer star p, and I will call my alloc %p 20. Then in the stack memory, it's going to be p, and currently it's garbage. That says 100. And I have a return location is the line after. This function is void. So there's no value address. Then I have a PTR. I want the address, so the address is 100. Because I'm giving the PTR. This will be 101, 102, and n is 20. So let's think about this. Every time you add n% in front of a variable, the type needs to add 1 star. Think about this. If you have integer a equal to 5, you say n% a, that's going to be an integer star. So you have an integer star p, you add n%, that's going to be integer star star. Yes? I thought you raised your hand. Okay. Yes?
Why would you send the pointer to a function?
Why do I say point? Because I want to modify this one. I want to modify this.
But you could send just an address. Like b is just an integer.
Which one? P is not integer. P is
It's a pointer.
a pointer.
Yeah, why would you send the pointer to a function? Why
Because that's my definition of function. I want the function to allocate memory for me. So that after the function, I can say P0 equal to 5, P10 equal to minus 2. I want to create an array. But I want to create an array inside the function. Does that make sense?
yeah.
And this is the first function you need to do for assignment 3. You need to create an array of characters for your string. Okay?
In GDB, if you want to see the value of the PTR, so you just print PTR and it will show you the value of PTR.
Yes. If you just say print PTR, yes.
And that's gonna be a memory address.
If you have allocated, otherwise garbage. Currently, this is garbage.
How do you know if it's garbage or not?
Okay, very good question. I'll answer that in a moment. Yes.
Over here, star PTR would point to garbage.
Star PTR will point to garbage right now, correct. Because currently PTR is garbage. So star, okay, star PTR,
How can such thing exist?
actually no, I'm sorry. Using PTR or P?
PTR.
Star PTR is what? Take PTR's value as address, go to that, yes, that's still garbage, yes.
Is that gonna work? I mean,
Not yet, stay with me. Okay, I want to modify this. So if I say PTR equal to malloc, if I say that, what's going to happen? Which one am I going to change?
you're going to change the value.
I'm going to change the value, so which memory address is this? It's going to change. Somebody from this side. It's too quiet here. It's more questions from that side. Interesting. If I say PTR equal to malloc, which one am I going to change? Which memory address?
P.
I don't know what's P. Computer doesn't have a P. Computer only has address and a value.
I'm going to change the 100.
Address 100.
If you say PTR equal to malloc, which address are you going to change?
102. 102.
102. When you say PTR equal, which memory address do you change?
102.
When you say integer equal to 5, a equal to 5, a it has address, let's say 200. Which memory location are you going to change? 200. You'll change here, right? When you say PTR equal to something, which memory location do you change? Address do you change? You're smiling. You want to tell us the answer?
102.
What?
2.
102. Right? If you say PTR equal, you're going to change this one. Is that what you want?
No.
No. You want to change this one. Right? We did it earlier. If you change PTR, that's not going to change P. So you're not going to do that. You're not going to change this one. You want to change this one. How do you change this one?
Star.
When you say star, you take 100 as address, multiply the value at that address. So you are going to change this to 50,000. Assume malloc give you 50,000.
Shouldn't it be double star?
So you need to have double star here.
Just there, but not.
Not here.
Oh,
Okay, so the type, I know for every semester, students are confused about type. You have type, you have x. You add in front of x, this type will be type star. Okay? You have type star y. This is creating a pointer. Your star y, the type will be type. So maybe this is too confusing. So I have integer x, ampersand x, that gives me integer star. I have integer star p. Star p gives me integer. And if you have a star star, that gives me integer star. Every time you add one star in front of a pointer, you take one star out from the type. So if you have a star here, this gives me use one star. Every time you add ampersand in front of the type, you add one more star in front of the type. So x is integer star, ampersand, add one more star there. If p is integer star star, star p, take out one star, so it becomes integer star. That's the reason you need to have this. If you don't have this, PTR, you are going to modify this address, not this one.
Can you please put the paper?
This one?
Yeah.
Okay. Okay, any questions? This class is too quiet. Means everybody understands everything.
We're trying to digest.
Ask questions. If nobody asks questions, I teach more and more. I speak faster and faster. That means more and more material for the exam. So it's your choice. Yes, please. Thank you. Let's give him a hand. Thank you for asking questions. Go ahead.
Would there ever be a reason to use like 3 stars in front of P?
3 star is 2 star is pretty common. 3 star less common. 4 star very rare. 5 star is you. There are different ways to do things. Once you go to 3 star, it means you probably want to do something different. We'll talk about that. You probably want to create hierarchy of data types instead of using many stars. Yes.
I don't really get what you're saying by this page right
Okay. Types. If you have something like integer x, I always use integer. I assume that's something everybody is familiar with. Is that a reasonable statement? Everybody is comfortable with integer? Okay. If you add ampersand in front of x, the type becomes integer star. So if you say integer x, and you want to say p, and you say p equal to ampersand x, what's the type of p? Integer star. Because when you add ampersand, you take the address. X is integer, the address of an integer is integer pointer. If you have an integer pointer, p, and let's say p, okay, maybe I just continue. So you say x equal to 5. That means star p is 5. Because p is an integer pointer. You add 1 star. Notice I don't have integer in front. So remember I have 4 different ways to use star. This is creating a pointer. This is not creating a pointer since I'm not writing integer in front. So I'm taking p as an address and read the value from the address. What's that address? That's the address of x. Therefore, this one is integer. Yes?
When you, let's say you declare integer star p and then you immediately assign a value to it, is it gonna give a p
You mean this
memory
way?
address?
You mean this way?
One up.
Which one?
Up. No, yes.
What do you want to do?
If you put equals, let's say 5, it's gonna crash, right? I mean, it's gonna be a memory leak.
Not memory leak. 5, you mean you assign 5 as an address, right? Remember?
Yeah.
Okay, let's take this into 2 steps. Let's take this into 2 steps. You'll say integer star p equal to 5 is the same as integer star p and p equal to 5. That's what it means.
Okay.
Okay. Remember p is a pointer, so p's value is an address. So you are saying I want to do something with address number 5. That's what you intend to do by writing this. How do you know address number 5 is accessible to your program? You don't. So you get compiler warning.
Is there a way to check
Check what?
if there's a memory like that?
Why is there a memory leak? Memory leak only happens if I have a malloc. I'm not doing malloc.
Well, I mean, like if you're trying to access a memory that you don't know what's there, so can you check if it's free or not?
No.
Okay.
You cannot check do I have access to that piece of memory because you don't. The only way you have access is either in the stack or from malloc.
Can you go back again? To the
This
same-
way?
Yeah, and one back, one page more.
I don't know which page. This page?
You had many more types and.
This way?
Yeah, that one.
Okay.
So you have that integer double star p, and then star p implies integer star.
Yes.
So if you put address, ampersand p, what is that gonna be?
Ampersand
Three
p.
stars?
Gives you what?
3 stars?
3 stars.
What does that mean?
Okay, so come back here. P is, this one will store address, and that will be at address 50,000 will be an integer. That's why you can say P0 equal to 5, P10 equal to minus 2. So PTR's value is an address. Another address is another address. Another address is integer. So you have to get to integer, you have to do 1, 2 steps. That's the reason PTR is star star.
Okay.
Okay. Yes.
In this function, we are allocating an array, right, of size 20.
Yes.
So then inside the function, if I want to access the first location of the array, then would I say star ptr of 0?
Yes.
Okay.
Wait, what was the question again?
If you want to access this memory,
The value.
the value you want to access this one, do you have to have a star in front? Yes.
And if I don't put the star, then what happens? Is it
Then,
just
if you don't put a star, PTR is 100.
yes.
So you want to treat this one as an array.
It won't.
You will get P actually, but that's not what you want to do, right? 0 is okay. If you put 1, it's problematic. Yes.
In this function, the p of 0 and the star ptr of 0 is the same thing?
P of 0 and star PTR, yes.
Okay.
Yes. Okay. Now let me answer your question. I'm sorry I keep you waiting for so long. Okay. So pointer to pointer, string is a pointer to character. If you have an array, means it's another point, so if I have an array of integers, that gives me integer star. Because I already said, if you have an array, let's say P0, that gives you integer. So if I have an array of a strings, that means you have a string star. But C doesn't have a string. In C, string means it's character star. Therefore, if you have an array of strings, that will be array of character. This will be a two-dimensional array.
Are we gonna see that in this class?
Say that again?
Are we gonna study two-dimensional array in this class?
If you want to do assignment 3.
We've never done with anything two-dimensional in 1 to 9.
Which course are you taking? Did you answer your question? Thank you.
Yes, I missed the class.
If this is assignment 259, why are you sitting here?
Oh.
Can you answer that question? You're smiling. If this is the same as 159, why are you sitting here? Some people are smiling. Did I say anything meaningful, or is this complete nonsense?
I mean,
Did I answer your question?
yeah.
Okay.
Are you gonna?
Don't you want to learn something new?
Yeah, I mean, are you gonna teach or did I miss it?
No, I haven't told it, but that's what I try to do in the next 5 minutes. Okay, so what is a string? A string is an array of, let's say, You may have an additional space, but we don't care. Once you have a /0, that ends the array, that ends the string. Okay? Now if you have a multiple string, let's say E, C, E, let's say C program. So you have an array, you have many strings. What you can do and what you usually do, almost what you always do, is you have an array, a pointer. Each string corresponds to an array. Each array corresponds to a memory location, a piece of memory location. So you have this one will be point to different memory locations.
Is it going to be continuous? Let's say you.
This is contiguous along this one string. This is contiguous, but this is not. So what you're going to do is you are going to create, you say string array, and then you will say string array equal to malloc size of how many you have. You need to start here. Your size of here is whatever type you have, remove one star.
Does that mean it's an array of pointers?
Correct. So this one will make str arr point to this piece of memory. And then str arr0 need to allocate the memory again. Now, once you get one dimension, you remove one star. So this one is going to be character star. And once this one is character star, size of this one has only one, has no star. And then let's say this is length 0. And this one will be length 0. This one will be length.
Is there a star after the character, like size of character?
Which one? There's one star here. There's no star there.
Okay.
You need one star because you have star star. You have star star size of, you remove one star. Once you have the first element, this one will be character star because this will be an element. Therefore, this one will be character star. This is character star, so there's no star there. And if you have a many array, many strings, you need to do str arr 1 malloc. You probably will put this inside a loop. For every malloc, you need to have a corresponding free. So later you need to say free you probably put into a loop as well. After you release this memory, everything here, then you say free str arr. So you release this memory. What you allocate first, you release later. What you allocate later, you release first. Follow that rule, you'll be fine. Now this probably reminds you the concept of stack, right? First in, last out. Don't mix that order. Then you'll be fine. Yes?
We allotted STAR of 0 first and then STAR of 1 first, right? But if you free them in any order, does it matter?
It doesn't matter, but you try to follow this rule to reduce mistakes. That's the general principle. Yeah, yes.
So if you forgot and you just said free STRARR, that would cover it, right?
Yes, if you just do this without doing this, then since you have malloc here, you still have this piece of memory, and that will create memory leak.
How do you access, when you put brackets, you access the row number, right?
Yes.
How do you
Two.
access the value inside the row number?
You want this one or you want this one?
No. So that one divides into many, no.
This one.
Those ones, they divide into many,
String.
many
Characters.
Many characters, and if you want to access, let's say, character number.
Let's say this is C
The third character.
program. So this will be index 0, 1, 2,
Yeah.
3. So this will be 0, 1, 2. So if I say 3, that gives me R.
Can you please put that so I can copy?
Sure. I put it here. Do you want to take? Okay. Every each lecture, I'll be happy to give away my writing if somebody wants to take it. Okay. If anybody wants asking, yes.
So the star array brackets 2 point to the character C, the address of character C, right?
Start 2, that points to the address of C. Correct.
So if you do plus plus in n, will that go to the next?
Yes. If you do plus, no, you cannot do plus plus because you do plus plus, you modify this, you lose the address of C now.
Yes. Plus 1. I mean, if you say.
You can do plus 1.
No.
You don't want to lose the address of C because that's your beginning. You don't want to modify. You don't want to modify this. You do not want to modify this.
I mean, I want to go to the next character.
Then you can say st. Then you can you can do this. You give another pointer. You say p equal to str arr 2, and that will be the address of a character C here. This one. You don't want to modify this. You can say p plus plus, but you don't want to change this one. Does that make sense? If you change that one, you lose it. You want to keep it because later on you say free.
But that way I actually can go to second character, but I lose the address, right? If I just
Later, if you say free, since if you modify this one, you are not releasing the whole piece of memory.
if I go to second character, it will only release from the second character.
Yes, if you say this
Okay.
one, and then later on you say free,
C will still be there, right?
C will still be there, so you have a problem.
Okay.
So that's bad thing. Does that make sense?
Yes.
Okay. Yes, please.
You said char star p and p equals to strr.
Yes.
Do you have to put an ampersand before strr?
If I put ampersand, what type do I get?
Okay.
This one is character star, right? Because strar is star star. So once I take one dimension, I remove one star. So this one is character star. Go back to the type. I know many students have a problem with type, so make sure you understand this very well. You take one dimension, you remove one star. So this one, strar2, is character star because you remove one star from here. So if you add ampersand, this one becomes character star star, then you have type mismatch. P is not only character star. Yes, please.
So the string C program, if I wanted to replace that string with hello, how would I write hello to that?
Okay, if you want to change, suppose you have enough space here. Let's say you want to change the second one. You will say strcpy. Assume you have enough space. Because this one corresponds to a string.
Okay.
Does that make sense?
And it's not gonna remove what, if the str array 2 is something already, let's say, per view, which is longer than hello.
Then you'll be fine if you do this. If it's too short, if str_ar2, remember we need to do allocate.
So the remaining, is it gonna be there? I mean,
This will become hello. You have special character
so
there.
whatever's there, it's done?
No, the memory is still there, just you don't care.
Yeah, but then the okay.
Okay, yes.
If you have to write the definition of strcpy over here, the pointer for strarr of 2 would be character array of.
No, if I add one index, I remove one star.
No, so if I want to write the definition for strcpy over here,
strcpy needs character star.
character star.
And strar is character star star.